Hello gang, Chef21 here. We are starting the CAD work for the Voron V0.1/V0.2 build. And we are going to do the top, or what is known as the deck panel, and the mid panel today. I'm just going to walk you through how we work through those. We're in Inventor. It is my preferred software for doing CAD work. Not everyone likes this one, that's fine. There is included in the Voron repository measurements for the deck panel and the mid panel. As you know, my mid panel is a slightly different setup. The deck panel is going to be exactly the same. The deck panel is 209 millimeters wide by 172 millimeters deep. And thickness is a question which we can answer. I believe we want to go with 3 mil thick. I'm just going to grab my calipers here and we'll check. Yes, 3 mil thick should be sufficient. The gaps are 3.2 in the rails, so 3 millimeters is what we want. Now this may be different than how you do it. If you're designing your own, that's okay. I prefer to do mine slightly differently. I like to start with a piece and then work out from there. So put a construction line down the middle. Let's work off because there's an 87 millimeter wide gap, shall we say, centered on that line. That's 24 deep, 87 wide. If we're clever with our construction lines and our constraints, we can snap them there. One other thing that we have in the corner here is an 18 millimeter deep by 15 millimeter wide cutout for our cable chain to mount. And then up in the front here, on both sides, there are 6 by 6 millimeter cuts as well. So get all of those and extrude them out. Now that gives us a nice looking piece. However, all these sharp corners are not really all that nice, so let's grab the fillet tool. This sharp corner we need to leave, but these two we can go away. Clever, you can grab the fillets that you can't quite see. We're looking for it to highlight the line. And if you grab a line you don't want, just hold Control. I think I want to go to a 3 mil fillet. Actually, let's stick with 2. 2 looks good. Okay, so that's your basic deck panel build. But it's no fun if it's just the basic deck panel. So I'm going to lay out some more construction lines here. Again, one down the middle. One over here. And then we have the polygon tool. Grab a hex. And let's see how big we want that hex to be. Go with 90. Now within this hex, we can do a couple of things. We're going to draw out the logo here. And another couple of construction lines in because that'll help us get this all set. Of course that moved. Okay, so we'll lock that down. We go here. All right. Now there's one that goes from up here to down here. I need to pull up the logo real quick. Give me a second. Okay, so I've got the logo and it's about how I figured it was. So that needs to be a construction line. So construction line here and here. Those two are parallel with each other and perpendicular to that. And this point goes there. That one goes there. Okay, that's a bit wide. And I gotta go check a couple things. I'll be back in a second. Okay, so we are back, and yeah, so these are slightly tricky. We'll get them sorted out very shortly. We'll get one last piece done, which is a couple construction lines from there to there, and from there to there. After that, that is just a matter of drawing out everything else. Now, the trick get all of these lengths the same. And we're gonna go with like 8 mil. And now I need to figure out why I'm so over-constrained I can't move things. So, show all constraints. I should in theory be able to move and get some gap between these two and those two. And it'll just change the angle of things. I think it's those I need to snip. What is your constraint dimension here? Fix that one. Then we'll put that line back in. Ew, is it because it's tied there? That's weird. We'll hide constraints, and we will see if I can get, there we go. We'll just try 8. We'll try 8. Weirdness. Is that really gonna be those? There we go, I think. Check a couple things. And that's 8. That's also 8. Yep. Okay, so we got 8, 8, 8, 8. That does not look quite right, so space that at 12, 12, 12, and 12. That looks better. Alright, so that, we can finish. Extrude that down to 0.6. That gives us 3 layers. 3 layers is about as far as you want to go. Right. And then we'll do one more thing. Another construction line. There. Perpendicular to that side. I'm going to go 20 mil down from that point. So we're going to grab the text box. We'll figure out font in a minute. Okay, so this sometimes happens. And it's easy enough, if I remember correctly. Basically, just need to take the equivalent here, take that line and that line. Or you just start over. I need to go. Open that line perpendicular. Nope. Okay. Take this, rotate it around that point, right there. That there. We're going to go and hit up, say 15 mil tall. So we'll hit a 5. We will center it and center it. And then because we know that this is 209, we can offset it from the side. 209 minus 85, 5 by 2, center it directly under everything else. We'll make that 18 tall. Makes sense? Other way we could do this, if we didn't want to go that way about it, and probably this will be easier in the long run. We hit another construction line there. We plop one in there. We hit our curvilinear. We snap the two together, dead center. Go back to our extrusion. Turn it into a cut. 0.6 again. Okay. There is the top side of our bottom plate done. I need to do some looking. figure out what mounts on the bottom. Once I've done that, we'll come back and we will get the bottom side finished. Alright, so the only thing that officially mounts to the bottom of this panel is the power supply. We're going to flip this over. I'm going to pull up the picture here, or the manual, and we'll go into sketch mode. Now the power supply itself, a bit of construction line going on here. This is a not small item. It is 97 millimeters wide by a whopping, too big for even my calipers to measure. Call it 160 long. Okay. And there are 2 mounting screws, and then we're going to do a couple other standoffs. But we'll do the mounting screws first. The screw locations first. Left the construction line on. We'll just put in 4 mounting belts right now. At 10 mil piece. Alright. We're going to put some heat set bosses in here so that we can bolt this thing down to the bottom because I don't feel like sticky taping it and I don't want to drill through this plate. Right. So first one needs to be grab a calculator. 3.64. Plus 3.66. So 5.8 from this edge. 5.48 from that edge. And and 4.65 from that edge. I'll just start deeper, so I gotta go check that. Okay, first mounting hole has been figured out. At least the boss has been figured out. Second one is more of a slot, so it's gonna be a little tricky to figure out, but it shouldn't be too bad. That's the opposite corner. It is, where is my mouse? This one here. I'm gonna drag that guy right in there, and then we'll get close. So 0.48, or 4.8, excuse me. So we're going to need to be 0.62. I want to call that about 2.2 in to the center. That looks about right. Now the rest of these, we're just going to kind of drag inside like this. And I'm going to hit them with tangent constraints to there. So that it can't kind of rock all over the place. Finish that up. And we'll extrude these out about. See how deep these thread sites are. These are only 4 mils, yeah, so 4 millimeters deep. So we'll go to 5. And I'm doing that because I don't have enough space to back cut these into this plate, so the plastic that is forced through is not going to catch. Now, one other thing that I need to do, we need to get this inside of this box. I want it inside, but just about 5 mil. That gives us a path here for cabling. And space here for cabling over here. Not to mention, we've got the power converter that lives here and the SSR that lives there. So we need to make sure that we can maintain that space. Pretty sure there's an SSR that lives there. Maybe just power converter. Not just power converter that lives over here. So we will, we need to do one more thing first. Or several things. Because we're using thread certs and heat set inserts, I need to clearance a hole for them. The thread threads that I have, a major diameter of 5 mil, and a minor diameter of 3.9. So that's 1.1 mil. So I like to oversize them by half of that distance. So we're going to go with 4.45. 4.45 millimeter. Oops, that's not what I wanted. 4.45 mil. There we go. That one and this one. Finish that. Oh, extrude. That and that. I'm going to cut. I want to hit 6 mil. As for looks, I'm going to hit a slight fillet on these, so there's a little more material to bind them as well. And we'll go with a 4 mil draft there. Right, so that plate. Let's see. Yeah, I think we're okay on cable management on the bottom. If I need to, I'll put some stickies down. But I think for the most part, we're pretty good. Actually, no, we're going to put some cable management spots. A couple of loops here, a couple of loops here, a couple of loops over here. It'll be pretty quick. We have a 10 mil by 20. 10 by 20. And 10 by 20. Collinear these two. No, it's already done. Those should be as well. Set them. Then we'll go in 10 mil from there. And this first one in 50. Second one in 40. This one in 50. Actually, we'll go 60 in and 60 in. I want them back from about 5. Now, we'll extrude these up 10 mil. Go 6 and 6. Actually, we can go 6 and 8. I'll set them 2. 2. Reason that didn't get the 8. 8. 8. Alright, those are done. Cut through all. Okay. Then we come back. Now, the way I'm doing this is this channel to run them through, and then space to run zip ties. We finish this off and we'll come back when it's done. Okay, so we've got the zip tie points mounted. Right, let's try. Okay, so now we've got the zip tie points mounted. Those are all there. We've got the mount for the power supply. So we're all set on this panel itself. So we'll save that as V0.1, 0.1, bottom, main. Oh, for crying out loud. There we go. Now, we're going main. Why main? Well, because we got more to do here. Remember how we put that hex in? Yep. We got another one to do. Back to document settings. I like to run everything in inch, but only because it's easier for this one. And that original one was 90. Right. Go pop this back open. 90s and 12s. Yeah. Oh, here we go again. 90s. And 12s. I just need to lock this to the center here, so 45. Actually, I don't really need to do that. It's just going to be a thing. Turn off construction. Line, space, line. Do need a construction for this one. Line. Go to line. Line. Another one. Okay. We'll check to make this easier. That's collinear there. That's collinear there. Those two are collinear there. That's an equal. That's equal. That's equal. Those are equal. That's equal. 12. 12. 12. Now, going back to the first drawing. Remember that point was constrained to this line, and that point to this line. Okay. Now we've got those. Let's get these construction lines back in and reconstrain everything to those. Okay. Let's try parallel constraint first. And parallel there. Okay. Now we can collinear these two, and those, and that. Okay. So that goes to there, and that goes to there. For some reason those... Yeah, because these never hit a parallel constraint. There we go. Easier once it gets done. Okay. Not sure what that arc is for. Right, everything is locked there. Right. So this is locked in, but that's only half of what we need. Remember, we did this as well, so we need 2 more construction lines here. And ensure that this is perpendicular to that. And 20 mil below, right? 20 mils off the bottom tip. Now we need a text box. Right? And do the rotating bit. Right? We will snap that to there, snap that to there. Double check 18 by 85. Go to 18. Go to 85. Pop this open. We went to 15 mils and centered and centered. 15, centered and centered. Voila. Now the fun part. We could extrude. We grab both of these. And we're only going to extrude 0.6 millimeters. We'll save that for bottom insert. And just so you can see what this is going to look like, go with the dark green. And we will grab a new assembly. The bottom main. We'll ground that panel because it doesn't need to go anywhere. We'll grab the bottom insert. That surface to that surface. Okay, this is just one sweeper. Basically, that's how it's going to look. That V bottom panel looks from the top. So that's what you'll see underneath the under the bed through the door. So that's all set. Set that just as. All right, bottom panel is done. Everything that needs to happen there has happened. Let me reset and we will get the back panel figured out here. All right, so under the back panel, I'm going to start this off the same way. grab a angle, over to millimeters. Need to be 230 wide. There's a print for this. Print is 170 tall. We gotta add 100, so 200 and 170. We are going to extrude this out to 3 mils, just like the last one. And we're going to put 2 millimeter fillets on the corners, just like the last one. Then going on to the front here, we need a construction line. And actually, we need 2. More construction lines off to the side, because we've got some holes that are going to mount to those. And there's the center of those holes is 69 millimeters from center to center, which means we're 34.5 off of each side. Now I only put, I'm going to do this just so that they're all in the same place. I think I only put 3 sets of screw bolts or nuts in the back here, but let's pick it up and find out. Yes, only did 3. And I did that for a couple reasons. The print that is shown has provisions for a Bowden drive. We're not doing that, so I can lose 2 more on one side. I also don't think it's super necessary to have more than that. That being said, I'm going to change the spacing out a little bit. So I'm going to do 1 set right through here, right in the middle. Put another set down at the bottom, another set at the top. Now it has them 7.5 mil down. That's awfully short. So I think we'll go 10. And we'll go 10 up. And that leaves us with just the centerpiece, which we will put in the center of the part. However, we get slots. Got to turn construction off. I'm going to draw this slot in a way that makes sense. So they call out a spec of 4 wide, center to center, and 3.4 tall. Now they have a nice tool here. And that gives us all 6 of them that we need. Drag them close to where they should be. And then we can use the point tool right there. Get those all locked into place. And then we can use the curl in here and slam that one into place. So there's the holes we need. That's done. Now it calls out 2 holes that I have no idea what they're for, and I'm just going to leave them. And by leave, I mean leave them out. I think those so you can get to the mounting screws for the flange nut that controls the bed height. We're not using that system. My dimensions are different than theirs. I'm going to leave it off. But there's one more thing that we need to put in place here, and that is a little rectangle here. It's 5 mil deep and 8 mil wide, and edge of it is 12 mil from there. So I just want to check that it's, yeah, okay. So that's good. We'll finish that off. We're going to cut all of these out, grab the fillet, and we'll hit that one with 2 mils. And there is the main piece done. Well, I say the main piece. There is the back panel done in whole. We're going to do similar things on this one as we did on the other one, but not quite the same. So for right now, I'm just going to grab a sketch, toss a text box on there. Doesn't need to say anything more than that. Doesn't need to be anything more than that. We'll finish that sketch and that can stay there. We'll flip this over and I'll start on the back here in a second. Okay, going to the bottom, or the back as it is. The manual shows mounting the Raspberry Pi and the SKR Mini to the back panel. Now I'm all for this. I like this idea. I don't necessarily like the location, but it's one we can work with. There's a couple of guys who have done various modifications. And I want to see if I can pull a picture of how they've done it, because I liked what I saw. I just don't remember how they did. One of the things that I want to not do is to use any adhesive for mounting the electronics. These panels tend to get very warm during operation. I would rather screw the electronics in than have them floating. That's not quite what I want. Let's see. Okay, so this isn't too bad. So what they've done is they've mounted the Pi down here, SKR, and remember this one is 100 mil taller, the SKR over here, and they've run the cable channel up through the middle. Now we're going to do something similar. So I'm going to be able to zip tie the cables down because I do have the umbilical backplate, which we will be using. I want to sort of do that. And this makes it so we don't have to use the mounting brackets. We can use heat sets, screws, and fine tune the location as we desire. So first things first, I need to pull up a mechanical drawing for the Raspberry Pi, which has our mounting locations on it. I'm going to do this all at the same time. Thankfully, Avery has this drawing. And we're going to do a construction line rectangle to the size we need. So we need a 49 by 58 mount. So that's for our holes. I'll do another one. That's the entirety of the Pi. The Pi is 85 by 56, just so we can get an idea of where everything mounts. That's about 5. No, 7. That's 3.5, excuse me. And 3.5 this way as well. I don't want to have any. That's the other thing I don't quite like with their original location for mounting things, and then I want to address with this one. They had it so that to get to this mounting screw, you got to take off the Pi. I can understand why, but because we're using the umbilical, we don't necessarily need or want that. I'd rather we be able to take the entire back panel off as an assembly than have to remove this to get to the back. I don't want to unplug everything. Less unplugging, the better. So we're going to do that. And I may rotate this 90 so that you can get to the SD card without taking off the side panel. Because if I can have the SD card pointed up and down, that'll be even better. So, but for now though, that's where we sit. Now I need a SKR AE3 mounting locations. Okay, and thankfully someone has one. Let me just make sure I'm running a mini E3 we're planning to for this thing. Alright, box has E3 on it, but it's E3 V3. So let's pull it out of the box here and verify. Yes, everything looks correct from the wrist drawing I got pulled up. I want them mounted kind of on the same plane. So I'm going to pull up this big drawing here. Okay, so first things first, we need a rectangle that is 103.75 long by 70.25 wide. Okay. This one is going to be a little tricky to keep off of at least one hole, but I should be able to do it. And remember, I can move these too if I want. Now, I just want to check how I want to have this oriented, because it will matter. It will make a difference to us. I have it mounted with the USB and the SD card pointed down. So, oh, that's a sort of useless dimension. I'll have to take it out of the package and get one dimension here. So we're out of construction mode, and there's 5 mounting holes, and we're only going to use 4 of them. We don't need all 5, I don't think. We got one here. We got one closer there. Got one here. We've got one here, and we've got one here. Set these all to be the same size. These are all 3mm holes. From this hole to this hole is going to be 64.46. From this hole to this hole is going to be 34.98. This hole to this hole is 62.15. And from this hole to this hole is 95.65. And I'm missing a couple of critical dimensions here, let's be honest. Because I don't have a dimension from this hole to this edge and this hole to this edge, which would set those two. And then I'm missing one from this hole to this edge, which would set this one. Yeah, and that would set this one as well. So let's pull this out of the baggie and see what we can find. It's one thing that kind of annoys me using other people's dimension drawings, is they're always missing a critical dimension. So let's find out the offset for those two holes on the side. Hole diameters to start with are 3.75. Cut that in half. And we'll call it 1.4. So 3 at 2, 7. So from there to there is 3.27. That looks about right. It's actually going to be easier to get this dimension than it is this dimension. I'll use the same screw hole size, because it's the same screw. $16.35. So that gives us 18.225. Let's set those two. Those two can't go anywhere. They're just where they should be. I'll make these the screw size just so that my 3.75, the whole size, just so I can check my dimensioning here. Because something's not looking correct. Just based on my quick look here. This one doesn't look right. But let's find this hole first, because I bet you this one will fix that one. I know I'm breaking GD&T rules here because I'm not dimensioning off of the same side. I mean, I could if I wanted to, but so we will, but I was going to round off the back. Okay, so let's go out to where we need to be. If I had to guess, about 96.6. 96.56. 96.5. 96.56. So we're at 98.435. That actually looks pretty close, so we're going to call that good. And that gets us our SKR V3 mounting locations. SKR meaning E3 V3. Now you'll notice there's the green. It's because this whole box can move in space. Ooh, that's an interesting thing. I'm going to put a construction line between these two. Put a parallel constraint on that. Okay, so that gets us our mounting holes. That one. Now, the holes on pi are a little bit easier because they're right here. Come off construction lines. So that's easy, but they're all their own. They're all their own size. This pi uses M2.5, so I don't have M2.5s, I got M2s. So we're going to have M2s. So these ones we're going to make a little bit different. I've got different heat sets for those. Those heat sets are about 4 across, so we're going to go about 8. And the heat sets for these are 5 across, so we're going to go to 10s. Now, let's figure out what makes sense here. Got all this real estate to use, and I want to run tie points up the middle here. And I don't know if I want to run tie points or I want to print in a cable channel, which I may just print in a cable channel. And some tie points across the bottom here for the USB. I think we are going to spin this 90. I'll take this whole piece. I'm going to spin 90. We're going to mount it right here, basically. And what we've got, because we're looking at the back, remember, so we've got the cable chain for the bed that comes up on the other side here. And we've got the power converter, which is right here, so we can run those lines in and over. We've got the USB, which we can run down and over. We've got all of our fans and other outputs here. We've got all of our stepper outputs here. Power inputs are here. Actually, excuse me, SD card is here. Power inputs are here. So this reflects my goal of wanting to have, power inputs and outputs are here. One of the headers is here. So this reflects my goal of having both of the SD cards accessible. We've got power going in and out here. I'll have power in and out here. The stepper outputs are going to have to traverse the board. That's not a big deal. Fan headers and everything are right here, so that's easy enough. So I think I like this spot. But let's get some hard numbers and some actual mount locations down for these. I like this about 6 off. And let's go 40 up. Let's go 50 up for this one. And 10 over. I'll put this dimension, how far? 87. Which gives us plenty of space for a USB cable to move. The USB cable may be the one cable not fully in that channel, which is fine. Okay, so now that we've got these all locked down, we can extrude these out the other way. There we go. Not as hard to see which way this is going. All right, as long as it's 6, I want another, let's make this 8. Thick total. We'll do the same thing we did last time. We'll hit these with fillets all the way around. Okay, and then we'll hit this with a different sketch again. Now we're going to do 2 different ones because these are going to be different depths and different hole sizes, I think. Actually, no, they're going to be 4 mils anyways, so we can do this in one go. The M2 heat sets that I have are 3.5 on their major and 3 on their minor. So that's 3.25 as an average. And we're going to make these all the same. We have to set one dimension. Right. And then we just double check why that one's not green, because it never got locked to the center of that. Or we can fix that with a coincident constraint. All right, now these, let's do 4.45 because we're using the same ones as before. Set one dimension, and we hit the equals constraint for all of them. And we extrude out the circles, the holes, flip it to cut, and we want to go 6, just so we have some extra space. And that's the mounting for the backside, for the electronics done. Wait a minute to check a couple of things, and when we come back, we'll do the cable chain on the back.